Greeting, ladies and gentlemen. Welcome from the presentations of the mini projects algorithm. So in that case, I made the algorithms for the booking systems, which consists of a lot of algorithmic process. Well, for the presentation styles, I chose to work with the Animaker websites for the AI presentation. And to be honest, this is my first time using some websites. So due to the lack of experience, I didn't expect that would go that smooth. But I hope you guys enjoyed it because it's so entertaining to watch. And plus, we also covers a lot of the topics regards to our presentations. And hope you guys might like it. My name is Lam Ming Yet, and my ID number is 651101442. So according to the presentation styles, the AI named Elliot. Yes, I use the characters Elliot in all of the presentations, even even inside the presentation slides. So I used the characters again in the Animaker's presentations too. So I hope you guys would like it, and let's start our presentation soon. So that will be also at the end, there will be the demonstration process of our code, whether how does it work or not. So I hope you guys please follow till the end, and hope you guys might like it. Thank you.
Hello, I'm Elliot. In this video, I'll be the narrator of the story. Basically, it's all about a complex algorithmic system which I was encountered during my last summer vacation. It's all started when I was trying to book for a flight. During that time I suddenly realized that a booking system consists of algorithmic complexity of coding. Therefore, I've decided to learn with the help of my friend, Louise, student from KMITL. So, let's get started. Before it has started, have you ever imagined how these days booking system concerns of which kind of factors during the operations? In that case, there will be basically two factors to be concerned according to the research. First is the efficiency and user interface, while the second one is the data integrity and security. However, momentarily, we are going to be emphasize on the most basic booking related algorithms of user interface functionalities, which is all about the idea of reservation. Though we all accept the fact of good booking algorithmic system contains multiple complicated coding for different functions to enhance the efficiency and better user interface. We focused only on this cornerstone factor this time. Thank you. Well, let's move to the another topic of class and data structure and algorithms. The flight class is the backbone of our flight booking system. It's responsible for representing individual flights with various attributes, making it easier for us to manage and organize flight information. Let's take a look at the flight class from our code. In this class, we define attributes such as flight number, departure location, destination, departure time, arrival time, price, and available seats. These attributes are crucial for representing flight information, allowing us to efficiently manage and interact with flights in our system. The flight booking system class is responsible for orchestrating the flights, managing bookings, and providing a user interface for interacting with the system. Let's briefly review the flight booking system class. In this class, we maintain two critical data structures, a list of flights and a list of bookings. These lists allow us to store flight objects and booking information efficiently, making it easy to access and manipulate the data as needed. By using the flight class and data structures like lists, our flight booking system can efficiently store, organize, and retrieve flight and booking information, enabling a smooth user experience for passengers and efficient management for airline personnel. Well, this time let's talk about the efficiency with an example code. Efficiency is crucial in our flight booking system. It ensures quick bookings for passengers and streamlined management for airlines. Here's how our code achieves efficiency and its impact on time complexity. In this code, goal is set for checking seat availability. Our system uses a linear search to check seat availability. As we scale with more flights, n, this operation's time complexity is O(n). If we consider for larger systems, we might explore efficient data structures like binary search trees. Well, here comes the interesting topic. The algorithmic booking design summary. Let's us use the previous coding again, but just for a brief. The design idea has simple 7 steps. Step 1: Input flight number. This step allows the user to enter an option to operate the system where the passenger could start doing their flight reservation. Step 2: Check flight availability. Our system will allow observe whether the desired flight's availability of seats through a loop with a list of flight. Step 3: Gather passenger information. If the flight is available, next step would be the reservation of the flight through the personal information completion. Step 4: Create a booking entry. Then the booking entry was created combining the selected flight and passenger information. Step 5: Store the booking. Afterward, the information inserted will be stored in the list of booking. Step 6: Update available seats. If the booking item is successful, the available seats for the selected flight are reduced by 1 to reflect the booking. Step 7: Booking confirmation. Finally, a confirmation message is displayed to the passenger. This message serves as an acknowledgement of the successful booking, providing peace of mind to the traveler. The reservation could be relocated through the system as well. This algorithm isn't just a technical process, it's a vital bridge connecting passengers to their travel adventures. It's designed to be efficient, secure, and user-friendly, providing a seamless booking experience for everyone. With the coding pseudocode of the system, where generally we have 3 main steps. And for now, let's begin with Step 1. Step 1: Class and Properties Assignment. During this state, we define the attributes of the system, which momentarily include flight _number, departure destination, departure time, arrival time, price, and the available seat. Next will be the Step 2, which consists of the flight booking class and the functionalities, which is declared as method. For Step 2.1, it associates with the declaration of main purposes, which are the flight-related information and booking operation. Then Step 2.2 collects the information of the available flight, while Step 2.3 store, list, and display those available flight. Later, the Step 2.4 begins to collaborate with the essence of our booking system, information which typically allows the successful booking to be observed on the display by entering the name of the client. Now lastly, let's try out this Step 3. The Step 3 is more like to be called main program, where the methods and input are collaborated for the user interface. Here, the methods are recalled and match with the client's input information. Hereby now let's us present our flowchart. This part used to be seemingly challenging for us, since the flowchart has to be obliged the rule of not exceeding over 15 boxes, while our system requires wide ranges of codes and complex steps. However, we eventually managed to generate one by blending much information from pseudocode and raw file into summarized version of context. Well, this time let's talk about the special feature of our system. Apart from the given methods, we basically applied inserting, grouping, and counting. However, apart from them, we also applied the method of searching, which is pretty obvious in the later progress of our system. Therefore, right now we're going to focus on this one. Searching. Once again, in our flight booking system, the search_bookings function plays a crucial role in helping passengers and airline staff to find bookings by passenger name. Let's explore how this function works and discuss the algorithm used for this purpose. So how search bookings function works. The primary goal of the search_bookings function is to locate and display all bookings associated with a specific passenger's name. This is particularly useful when passengers want to verify their reservations or airline personnel need to access passenger information. Here's how the function operates. This function employs a linear search algorithm to find bookings by passenger name. Here's how the linear search works in this context. It starts by initializing an empty list, matching_bookings, which will store all the bookings that match the specified passenger's name. The function then iterates through the bookings list, examining each booking one by one. For each booking, it checks if the passenger_name in that booking matches the specified passenger's name. Importantly, the comparison is case insensitive, allowing for flexible searches. If a match is found, the booking is added to the matching_bookings list. After completing the loop, the function checks if any matching bookings were found. If there are matching bookings, it displays them one by one, including flight details and passenger information. If no matching bookings are found, The function displays a message indicating that there are no bookings for the specified passenger's name. The linear search algorithm is a simple, yet effective way to find bookings by passenger name. It ensures that passengers and airline staff can quickly access the information they need, even in a system with a large number of bookings. In our flight booking system, several challenges and potential pitfalls need to be addressed to ensure a smooth and user-friendly experience. Here, we'll discuss some of the key challenges and how our code handles them, including checking for seat availability, handling fully booked flights, and implementing error handling and user feedback. Challenge 1. Checking for seat availability. One of the foremost challenges is ensuring that passengers can only book available seats. To address this, our code employs a straightforward check for seat availability in the book_flight function. Our system explicitly checks the available_seats attribute of the selected flight, ensuring that passengers can only book when seats are available. If a flight is fully booked, it provides immediate feedback, avoiding the pitfall of overbooking. Challenge 2. Error handling and user feedback. Error handling and user feedback are crucial aspects of a user-friendly system. In our code, we've implemented user-friendly error messages to guide passengers and staff. For example, when a passenger enters a flight number that doesn't exist, our code provides feedback. This ensures that passengers are informed when there's an issue and reduces confusion. Additionally, our code handles the scenario where no bookings are found for a specific passenger's name. It provides a clear and informative message to the user. These error messages help users understand the context of the issue and what steps to take next. In summary, our code effectively addresses challenges such as seat availability, fully booked flights, error handling, and user feedback. By providing clear and concise messages, we enhance the user experience, prevent overbooking, and ensure passengers can navigate the system with ease. This user-centric approach contributes to a more efficient and pleasant flight booking experience. Well, this time let's talk about the sample flight and how the user interface works. In our flight booking system, we showcase a set of sample flights to illustrate how they are added to the system. We also provide a demonstration of the interactive interface for listing, booking, and searching for flights. Here's how this process works in our code. The realistic flight booking system, we've included a set of sample flights. These flights represent different destinations, departure times, prices, and available seat counts. For instance, we have flights like AA101 to Tokyo, UA101 to Dubai, BA101 to Taiwan, and MA101 to Yangon. How about adding flight information? Sample flights are added to the system using the add flight method of the flight booking system class. For example, to add a flight, we use code like this. This process continues for each sample flight, populating the system with various options for passengers. Now the discussion leads to the interactive interface where we operate accordingly towards the user's inputs. We've designed an interactive interface for users to engage with the flight booking system. This interface allows users to list available flights, book a flight, and search for bookings using a passenger's name. During this presentation, we can walk you through a brief demonstration of how this interface works. Option 1. Listing available flights. Users can select this option to view a list of all available flights. This feature allows passengers to explore their travel options. Option 2. Booking a flight. When a user chooses this option, they are prompted to enter the flight number they wish to book. Our system then checks seat availability and guides the passenger through the booking process. Option 3. Searching for bookings by passenger name. This option is valuable for passengers and airline staff. Users input a passenger's name, and the system displays all relevant bookings, complete with flight details. Our interactive interface ensures a user-friendly and intuitive experience for passengers and airline personnel, making flight booking and management accessible and efficient. By incorporating sample flights and providing a demonstration of the interface, we showcase the practicality and functionality of our flight booking system. While our code represents a simplified version of a flight booking system, it closely mirrors the principles and core functionalities found in real-world airline and travel agency websites. Let's discuss how this code can serve as a foundation for larger, more complex systems and explore how the principles demonstrated here are applied in the real world. Core principles in the code. The code captures essential elements of a flight booking system, such as adding and managing flights, booking seats, and searching for bookings. These functionalities are the building blocks of any flight booking system. 2. Scalability. The principles demonstrated in this code can be readily scaled to accommodate a vast number of flights, routes, and passengers. Real-world systems handle a diverse and extensive array of destinations and airlines. With minor adjustments to data structures and optimization, this code can adapt to larger volumes of data. 3. User-friendly interface. Real-world systems prioritize user experience. The interactive interface showcased here, including options for listing flights and searching for bookings, mirrors the user-centric design of major airline websites. Streamlining the user journey and ensuring intuitive navigation are top priorities. 4. Seat availability and error handling. Handling seat availability, as demonstrated, is a critical function in real-world systems. Overbooking can be costly, leading to compensation claims and disgruntled passengers. By implementing proper checks and error handling, real-world systems avoid such pitfalls. 5. Feedback and communication. The code's user feedback mechanism is akin to the real world, where clear communication with passengers is essential. Whether informing passengers about fully booked flights or confirming bookings, efficient and transparent communication is vital. 6. Security and privacy. In real-world systems, passenger information security is a primary concern. The principles applied in this code can serve as a foundation for implementing robust security measures to protect passengers' personal and payment information. 7. Integration and connectivity. Large-scale flight booking systems often integrate with various other systems, including payment gateways, databases of flight information, and external APIs. The principles demonstrated here provide a strong foundation for developing such integrations. 8. Performance optimization. As real-world systems face increasing loads and complexities, performance optimization is paramount. Techniques like database indexing, caching, and load balancing, inspired by the principles demonstrated here, can ensure system responsiveness. In conclusion, this code serves as a simplified yet highly instructive example of a flight booking system. The principles and functionalities showcased here closely align with the real-world counterparts, providing a solid basis for the development of more complex, robust, and scalable systems in the airline and travel industry. As the industry continues to evolve, these principles remain at the core of delivering exceptional service and experience to travelers worldwide.
Okay. Okay, welcome from the demonstration sessions. And right here we have already seen we have 4 options to choose, which is the first one, it's the list of the available flights. The second one is for the reservations, and the third one it's to confirm our bookings and other related informations. And the fourth one is to be quick. So let's start with the first one to let us know the information of the flight. So right now we have seen 4 flights, which is inserted in the arrays. The first one is the flight to Tokyo, the second one is this flight to Dubai, the third one is a flight to Taiwan, and the fourth one is the flight to Yangon. Afterwards, we're gonna go to the reservations options, which is the number 2, to book a flight. So let's choose 2, and afterwards we can now insert the flights that we would like to book. So in that case, we're gonna go to Dubai, which is the flight numbers of UA101. If we face the issues of the unavailable flight, we're gonna see the script of fully book. In that case, we have to choose the other options to book again. So 2, this time we're gonna book a flight to Tokyo, which is with the flight numbers of AA101. Now AA101, okay. And if it's available, the other option is to insert the passenger informations. In that case, I'm gonna insert my name, La Minya. And afterwards, here we have the age options. In the real life experience, we can add other like information such as passport numbers and other informations. If it is successful, we have seen that the booking is confirmed here. Yeah, and for the third options, we need to make sure our booking systems
had completely noted or not. So let's see what the third options. Right now we have to insert our names again. Name, yeah. And if the bookings is available, we have seen the information related to our ticket here. Now our system is complete. So in that case, we have to quick from our system. So we're gonna insert the numbers of 4. Okay, right here is over. And that is all about our presentation. Thank you.